Welcome, dear listener, to a time of monumental ambition. To the quiet, rhythmic tapping of bronze chisels against solid stone. Close your eyes, take a slow, deep breath in, and let it out peacefully into the stillness of antiquity. Tonight, we journey across the ancient Mediterranean world, exploring the breathtaking engineering of the Seven Wonders. These are not just structures, but profound testaments to human geometry, calculated logistics, and enduring craftsmanship. Let the methodical, rhythmic stacking of ancient limestone guide your resting mind into absolute peace. The unparalleled precision of the Great Pyramid of Giza begins not with towering stones, but with the meticulous leveling of the solid limestone bedrock. Before a single block was laid, Egyptian surveyors excavated a vast, complex grid of shallow, interconnected trenches directly into the desert floor. By completely filling these precise channels with water brought up from the quiet river Nile, the builders utilized the natural, unyielding physics of fluid dynamics. The surface of the standing water provided a flawless, absolute, horizontal reference line across the entire 13-acre footprint. Surveyors then used stretched plumb lines and wood-in-a-frame tools to carefully measure down from the water's surface, marking the exact depths needed to cut the dry bedrock. Masons rhythmically chipped away the excess stone until the entire plateau was flattened to within a staggering fraction of an inch. This brilliant methodical application of hydrostatic leveling guaranteed that the immense, crushing weight of the future monument would rest upon a perfectly stable, unified foundation. Transporting the massive 2.5-ton limestone blocks across the desert required a profound understanding of friction and continuous, cooperative rhythm. Rather than utilizing wheeled carts, which would easily sink and fail. Soft earth, engineers constructed heavy, flat-bottomed wooden sledges from thick cedar planks. To overcome the immense drag of the dry terrain, a specialized worker walked deliberately at the very front of the moving sledge, carefully pouring a continuous, measured stream of river water directly onto the path ahead. This precise introduction of moisture chemically altered the microscopical structure of the quartz sand, causing the loose grains to temporarily bind together. This simple, deeply calculated act created a smooth, hardened capillary bridge, effectively cutting the pulling force required by more than half. A team of laborers could then smoothly and methodically pull the heavy stone forward on thick, twisted ropes of papyrus fiber, transforming the monumentally physical struggle into a steady, gliding, and completely synchronized progression across the ancient landscape. The structural integrity of the Hanging Gardens of Babylon depended entirely on an ingenious, multi-layered waterproofing system designed to protect the fragile mud brick foundations from continuous moisture. To prevent the deep roots and irrigation water from rotting the supporting arches, Babylonian engineers first laid a massive, perfectly flat foundation of massive stone slabs. Over this heavy stone deck, they meticulously spread a thick, viscous layer of naturally occurring asphalt, known as bitumen, heavily mixed with dried marsh reeds to provide structural tensile strength. Next, a double layer of baked terracotta bricks was methodically set into sticky tar, completely sealing the porous gaps. The final, most crucial layer consisted of thick, heavy sheets of solid lead, carefully unrolled and soldered together at the seams to form an impenetrable, watertight pan. This brilliant permanent chemical and physical barrier safely contained thick, deep, heavy layers of organic topsoil, allowing lush, towering trees to thrive high above the arid plains without ever compromising the structural vaults below, elevating thousands of gallons of fresh water to the highest tiers of the hanging gardens required the continuous, rhythmic operation of an advanced mechanical pump long before the invention of automated machinery. Engineers installed a massive spiraling device constructed from a thick, central wooden cylinder, deeply carved with a continuous helical groove. A tight, overlapping layer of flexible palm leaves and thick pitch was securely wrapped around the exterior of this wooden spiral, creating a sealed, internal water channel. The base of this heavy mechanism was submerged deep into the cool, flowing waters of the Euphrates River. As a worker continuously turned a crank handle at the very top, the internal spiral scooped up a small, sealed pocket of water. With every methodical rotation, the physical geometry of the screw slowly and peacefully pushed the trapped water higher and higher up the shaft. This incredibly efficient, quiet transfer of kinetic energy safely delivered a steady, life-giving stream of hydration to the highest, blossoming terraces. Constructing the massive Temple of Artemis presented a profound geological challenge, as the chosen site in Ephesus rested entirely upon a soft, damp, and highly unstable river marsh. Recognizing the immense danger of the region's frequent seismic activity, the brilliant architect Ctesiphron deliberately chose this spongy earth to act as a natural shock absorber. To stabilize the sinking ground, engineers excavated a massive, deep rectangular pit, methodically filling the very bottom with heavy, compacted layers of deeply charred wood. This thick bed of crushed charcoal provided a firm, highly porous base that would not rot in the damp soil. Over the charcoal, workers carefully layered thousands of soft, untanned sheepskins, tightly packed together to distribute the immense, crushing weight of the marble foundations evenly across the unstable earth. This brilliant, multi-layered padding system safely decoupled the rigid stone temple from the shifting bedrock, allowing the colossal structure to gently ride out violent tremors like a heavy wooden ship floating peacefully upon a rolling ocean. Transporting the colossal, 50-ton marble column drums from the distant quarries to the Temple of Artemis required a revolutionary approach to heavy logistics, because the soft, muddy roads of Ephesus could not possibly support the concentrated weight of a loaded wooden wagon. The architect devised a brilliant method of turning the heavy stone itself into a rolling wheel. Carpenters constructed massive, circular wooden frames directly around the curved outer edges of each individual marble cylinder. These wooden wheels were then securely connected by a heavy, central iron axle, driven directly into the center of the stone. By wrapping a thick, braided hemp rope entirely around the central wooden housing and pulling forward with a team of oxen, the entire massive drum smoothly and efficiently rolled across the soft earth. This ingenious, perfectly balanced mechanism completely eliminated the devastating friction of a sledge, allowing the delicate, heavily carved marble to arrive at the peaceful construction site completely undamaged and ready for vertical assembly. The awe-inspiring statue of Zeus at Olympia was not carved from a single block of stone, but meticulously engineered using a complex composite technique known as chryselephantine construction. Deep within the dim echoing workshop of Phidias, carpenters first erected a massive, highly detailed internal skeleton of strong, flexible cypress wood. This intricate wooden scaffolding provided the essential hidden structural support for the towering 40-foot figure. To replicate the smooth, radiant skin of the god, artisans carefully boiled and flattened hundreds of thin, delicate plates of imported ivory. These fragile, pale sheets were meticulously shaped over heavy wooden molds, then quietly and permanently pegged into the wooden armature using tiny hidden pins of pure gold. The intricate folds of the god's divine robes were crafted entirely from heavy, beaten sheets of solid gold, carefully hammered over raised bronze anvils, achieve a flawless, flowing texture. This methodical, multi-material assembly created an impossibly magnificent, lifelike monument that seemed to softly glow in the quiet temple shadows. The crowning architectural achievement of the mausoleum at Halicarnassus was its towering, pyramidal roof, specifically engineered to support a massive, heavy marble chariot at its absolute peak. Instead of relying on a fragile internal wooden truss system, which would eventually rot, Greek architects utilized a brilliant, self-supporting method of overlapping stone known as corbellé. Masons precisely cut 24 horizontal layers of heavy, gleaming white marble blocks. As each successive square tier was laid, it was deliberately shifted inward by exactly a few calculated inches, slowly stepping the heavy ceiling toward the center. To prevent the inward-leaning stones from collapsing under their own immense weight, each individual block was permanently locked to its neighbor using heavy, bow-tie-shaped iron clamps deeply sealed with molten lead. This incredibly rigid, unified stone matrix successfully transferred the crushing downward force of the 25-foot marble chariot directly into the thick outer perimeter walls, resulting in a perfectly balanced, enduring geometric masterpiece rising silently above the ancient city. The construction of the towering Colossus of Rhodes required an incredibly patient, upward building process, effectively treating the massive bronze statue as an architectural tower rather than a traditional sculpture. The master engineer, Ches of Lindos, began by establishing a wide, heavily reinforced circular foundation of white marble. Directly into this heavy stone base, workers vertically anchored massive, thick pillars of forged iron, creating the incredibly strong central spine of the Titan's legs. As the internal iron skeleton slowly rose, artisans cast the delicate outer skin in wide, curved plates of bronze. These heavy metal panels were lifted into place and meticulously riveted directly to the internal iron bracing. To allow the workers to safely reach the ever-increasing height, the statue was entirely surrounded by a massive, continuously rising spiral mound of compacted earth and timber. This temporary earthen ramp provided a completely stable, quiet working platform, hiding the magnificent figure for 12 years until the dirt was finally methodically dug away. Standing against the relentless, crashing waves of the Mediterranean Sea, the Lighthouse of Alexandria relied upon a brilliant, highly specialized chemical mortar to maintain its monumental, vertical integrity. To prevent the corrosive saltwater from dissolving the stone joints, engineers mixed their traditional lime cement with a heavy volcanic ash imported from the distant Bay of Naples. This unique silica-rich additive triggered a quiet, complex chemical reaction, allowing the mortar to actively cure and harden even while completely submerged. Underwater, forming an unbreakable, waterproof bond between the massive granite blocks. At the very pinnacle of this towering, three-tiered structure, architects installed a profoundly reflective, highly polished concave mirror, meticulously hammered from a massive sheet of solid bronze. During the dark, quiet nights, the intense, roaring flames of the central resin fire were geometrically captured by this curved metal dish and focused into a single, piercing beam of incredibly bright light, safely guiding weary sailors through the treacherous submerged coastal reefs. To protect the deep internal king's chamber from the catastrophic, crushing weight of the millions of tons of limestone above it, Egyptian architects engineered a brilliant sequence of relieving chambers. Instead of a single, flat ceiling, they meticulously stacked 5 successive layers of massive, rough-hewn granite beams directly above the burial room. Between each heavy layer, they deliberately left a small, empty pocket of all negative space. This carefully calculated vertical gap prevented the immense downward kinetic force from transferring directly onto the fragile ceiling below. At the very top of these 5 tiers, masons installed a pitched gable roof made of massive limestone slabs, angled precisely to permanently deflect the overwhelming weight of the pyramid core outward, safely redirecting the crushing compression down into the solid, unyielding structural walls of the monument. This invisible, profound mastery of structural load distribution has flawlessly protected the hidden chamber in absolute unbroken silence for over 4.5 millennia. The blinding, mirror-like finish of the Great Pyramid was achieved through meticulous application and aggressive polishing of fine Tura limestone casing stones. Masons quarried these outer blocks across the river, specifically selecting a highly dense, pure white limestone that lacked the porous imperfections of the core blocks. Once a block was dragged into position on the stepped pyramid face, the true, exhausting labor began. Stoneworkers used heavy dolerite pounders to roughly angle the face, followed immediately by continuous, rhythmic grinding using wide blocks of coarse sandstone. To achieve absolute optical flatness, they applied a specialized abrasive slurry made of crushed quartz, fine water, and pulverized chalk directly to the stone. Teams of polishers pushed flat copper plates back and forth across the slanted surface for countless hours, slowly erasing every microscopic chisel mark. This relentless friction, chemically and physically, transformed the dull, rough limestone into an incredibly smooth, gleaming, glass-like facade, engineered to perfectly reflect the harsh, blinding light of the ancient sun. To support the immense, crushing weight of saturated earth and towering trees, the architects of the Hanging Gardens utilized the unparalleled strength of the structural barrel vault. Because heavy timber was incredibly scarce in the arid Mesopotamian plains, engineers constructed a vast, subterranean labyrinth of deeply arched corridors, entirely from baked mud bricks. A temporary, curved wooden centering frame was constructed first. Masons, to methodically lay the wedge-shaped bricks, known as voussoirs, in a continuous, rising semicircle. The most critical component was the central keystone, perfectly carved to violently lock the entire arch into a state of permanent, unyielding compression. Once the wet mortar cured and the wooden frame was carefully knocked away, Overlapping geometric forces naturally transferred the massive vertical weight of the hanging terraces directly down into the heavy square supporting pillars. This brilliant, calculated distribution of kinetic energy created a cool, deeply shadowed, and incredibly stable artificial mountain upon the shifting, ancient delta, raising the colossal 30-ton marble architraves to the very top of the course. 60-foot columns at the Temple of Artemis required a brilliant, gravity-defying utilization of flowing sand, because traditional wooden cranes of the era would instantly snap under the immense structural stress. The architect Metageans engineered a slow, highly controlled method of hydraulic descent. Workers first constructed massive, tightly woven ramps of earth and timber, slowly dragging the heavy marble lintels to the absolute height of the capitals. Directly on top of the column, they placed tightly sewn, heavy leather sacks, completely overfilled with fine, dry river sand. The massive marble beam was gently levered directly onto these swollen sandbags. With slow, methodical precision, workers used sharp bronze awls to pierce tiny holes in the bottom of the leather sacks. As the dry sand quietly and steadily bled out, the immense marble block slowly, perfectly, and safely lowered itself exactly into its designated permanent resting place atop the fluted column. Shaping the delicate curving skin of the Olympian Zeus demanded a highly specialized chemical mastery over the rigid structure of raw elephant ivory. Because natural tusks are heavily curved and relatively small, ancient artisans could not simply carve the massive continuous sheets required for the gods' towering 40-foot torso. Instead, Phidias and his craftsmen employed a methodical, deeply guarded process of structural unrolling. They first used incredibly fine, sharply toothed bronze saws to carefully slice the ivory into long, thin, vertical cylinders. These rigid pieces were then completely submerged in a boiling, highly acidic bath of strong vinegar and fermented mandrake root. The continuous, rolling heat and the aggressive chemical acidity slowly broke down the tough, internal collagen matrix, rendering the impossibly hard ivory temporarily flexible and rubbery. While still piping hot, the softened sheets were carefully unrolled, gently pressed flat against smooth wooden blocks, and allowed to cool permanently, locking them into wide, flawless veneers for the magnificent, gleaming statue. To ensure the towering, multi-tiered mausoleum at Halicarnassus could withstand the aggressive, sudden violence of Aegean earthquakes, engineers abandoned traditional gravity-stacked masonry for a complex system of internal metal tension. As each heavy block of Proconesian marble was perfectly leveled and set into place, masons used sharply pointed bronze chisels to carve deep, interlocking, bow-tie-shaped grooves across the horizontal joints between the adjacent two stones. Into these recessed cavities, they carefully dropped thick, heavy clamps forged from solid iron, specifically designed to physically bridge the gap between the separate blocks, to lock the iron permanently and prevent the corrosive sea air from rusting the metal and expanding the stone. Workers poured a continuous stream of glowing molten lead directly into the carved channel. The liquid lead instantly filled every microscopic crevice, rapidly cooling and heavily contracting to naturally pull the adjacent marble blocks together with an immense, unbreakable, and profoundly enduring structural grip. The intricate casting of the colossal, bronze outer skin of the Rhodian sun god was achieved through the meticulous, deeply scaled process of lost wax. Casting. At the base of the massive construction ramp, master metallurgists sculpted exact, one-to-one replicas of the statue's muscular anatomy using a highly pliable, deeply refined mixture of beeswax and sticky pine rosin. Once the perfectly contoured wax panel was complete, it was carefully painted with multiple, extremely thin layers of fine liquid clay, capturing every coat, single microscopic detail of the original sculpture. This delicate shell was then heavily encased in a massive, thick jacket of coarse, heavily grog-tempered mud to provide immense structural integrity. The entire heavy block was slowly baked over a roaring, subterranean pit fire, causing the inner wax to completely melt and quietly drain away. This precise thermal destruction left behind a flawless, empty negative cavity, perfectly prepared to receive the glowing liquid bronze that would soon form Titan's enduring armor. As the towering bronze legs of the Colossus slowly rose above the harbor of Limnia Roads, the sheer vertical scale of the hollow metal structure presented a catastrophic risk of tipping in the heavy, violent coastal winds. To instantly correct this dangerous shift in the center of gravity, chairs of Lindos employed a brilliant, deeply pragmatic internal stabilizing method. Before the heavy bronze plates of the calves and thighs were permanently riveted shut, teams of laborers carried thousands of massive, heavy limestone boulders up the spiraling wooden scaffolding. These huge, irregular rocks were methodically dropped directly into the dark, hollow, vertical cavities of the bronze legs. By completely filling the lower extremities of the Titan with thousands of tons of dead, unyielding stone weight, the engineers drastically lowered the statue's center of mass directly down to the massive marble pedestal. This invisible silent ballast safely anchored the towering geometric marvel, ensuring the colossal figure remained absolutely unmoving against the roaring Mediterranean gales. To maintain the continuous, roaring signal fire at the very peak of the 400-foot lighthouse of Alexandria, engineers had to solve the profound logistical nightmare of transporting massive quantities of heavy fuel. Instead of designing a perilous, exhausting system of vertical ladders or simple pulleys, the architect Sostratus constructed a brilliant, continuously sloping, square internal ramp directly into the hollow core of the towering structure. This wide, gently inclined stone corridor continuously spiraled up the inner walls of the massive lower tier, engineered with a remarkably shallow, manageable gradient. This brilliant architectural feature allowed teams of heavily burdened pack mules pulling thick wooden carts entirely overflowing with highly combustible cedar and dried animal dung to walk smoothly and methodically all the way to the upper light chamber. This quiet, continuous, and highly efficient internal supply chain guaranteed that the vital, life-saving flames of the Pharos never once extinguished during the long, treacherous nights of ancient navigation. The legendary, piercing beam of the Alexandrian lighthouse relied upon meticulous chemical refinement of raw silica into a massive, highly reflective glass lens. Deep within the sheltered workshops of the Ptolemaic kings, artisans carefully melted a highly purified mixture of coastal quartz sand, natron, and crushed seashells inside a massive, roaring, subterranean clay crucible. As the molten, glowing glass was poured into a large, concave earthen mold, it was allowed to cool over several agonizingly slow weeks, specifically to prevent sudden, catastrophic thermal fracturing. Once the heavy curved disc was safely extracted, the true, exhausting labor commenced. Polishers used continuously finer grades of crushed corundum and wet emery powder, grinding the inner curve of the heavy glass for thousands of hours. This relentless, rhythmic abrasion slowly produced an impossibly smooth, flawless, parabolic mirror engineered to perfectly capture the chaotic, scattered light of the hearth fire and geometrically focus it into a single, blinding, concentrated beam of absolute clarity. To safely traverse the massive internal void of the Great Pyramid, architects engineered the breathtaking, geometrically flawless space known as the Grand Gallery, recognizing that a flat ceiling of this immense width would instantly collapse. Under the millions of tons of limestone above, builders employed an extreme method of continuous, overlapping corbelling. Along the sloping walls, masons precisely laid 7 distinct, ascending tiers of heavy limestone blocks. As each successive layer rose higher into the dark shaft, it was deliberately pushed inward by exactly 3 inches. This slow, methodical convergence gradually narrowed the massive span from a width of 7 feet at the base to a mere 3 feet at the absolute peak. By carefully stepping the stones inward, the overwhelming, downward kinetic energy of the pyramid core was gracefully transferred outward and downward, safely bypassing the hollow corridor entirely. This brilliant structural bridging technique produced a soaring, 28-foot-high vaulted ceiling, standing absolute and unyielding against the crushing compression of the ancient monument, extracting the incredibly dense, 70-ton granite monoliths required for the King's Chamber demanded a slow, deeply patient exploitation of natural botanical physics. Deep within the distant quarries of Aswan, stoneworkers did not attempt to smash the unyielding, igneous rock with fragile copper chisels. Instead, surveyors carefully located natural, microscopic fault lines running across the exposed granite bedrock. Using heavy dolerite pounding stones, workers painstakingly chipped a perfectly straight, narrow line of deep, rectangular slots directly into the stone's surface. Into these precise cavities, carpenters drove incredibly dry, tightly fitted wedges carved from porous sycamore wood. Once the wooden wedges were firmly seated, laborers continuously, methodically, poured cool river water directly over the timber. Over several quiet, tense hours, the dry wood actively absorbed the moisture, naturally expanding with an immense, unstoppable hydraulic force. This silent, relentless cellular expansion eventually triggered a deep, echoing crack, smoothly and flawlessly cleaving the massive granite block directly from the living bedrock, cultivating massive, deeply rooted trees upon elevated artificial terraces. Required Babylonian botanists to engineer a highly specialized, isolated, structural containment system. If left unchecked, the aggressive, expanding root systems of the imported cedars and date palms would easily fracture the baked mud brick vaults, leading to catastrophic structural collapse. To prevent this, architects constructed deep, individual planter boxes entirely out of solid, heavy blocks of non-porous basalt. The interior walls of these massive stone basins were meticulously coated with a thick, boiling layer of pure bitumen, completely sealing the microscopic pores of the volcanic rock. Before the rich organic river soil was added, the bottom of each basin was carefully lined with a deep, filtering layer of smooth river cobbles and coarse gravel. This careful stratification ensured that the heavy daily irrigation water could smoothly drain away from the fragile root tips, preventing deadly botanical rotary, while safely locking the immense, growing pressure of the trees away from the heart. Supporting arches spanning the massive, open-air cella of the Temple of Artemis required a masterpiece of timber engineering to safely support the heavy terracotta roof tiles, because a single piece of wood could not possibly cross the immense 70-foot width without sagging and snapping. Greek carpenters constructed an intricate, interlocking system of colossal wooden trusses. They specifically harvested massive, ancient cedar trees from the high slopes of Lebanon, renowned for their incredible tensile strength and natural resistance to burrowing insects. These immense logs were meticulously squared and joined together using highly complex mortise and tenon joints, completely avoiding the use of heavy, rust-prone iron nails. To securely lock the wooden beams, carpenters drove hardened, fire-treated wooden dowels directly through the overlapping joints, naturally expanding with the ambient humidity to form an unbreakable bond. This deeply calculated network of geometric triangles evenly distributed the immense, crushing weight of the heavy clay roof, transferring the vertical load silently and perfectly down into the towering marble columns. Preserving the delicate organic ivory skin of the towering statue of Zeus presented a profound environmental challenge within the damp, heavily forested climate of Olympia. Recognizing that continuous humidity fluctuations would inevitably cause the precious ivory plates to warp, expand, and violently crack, Phidias engineered brilliant, passive atmospheric control system. Directly at the feet of the colossal monument, masons excavated a wide, shallow, perfectly leveled rectangular basin into the dark Eleusinian marble floor. This specialized depression was not filled with purifying water, but completely flooded with hundreds of gallons of thick, pure olive oil. The heavy, viscous oil evaporated at a remarkably slow, continuous rate, permeating the surrounding air with a microscopic, deeply conditioning vapor. This gentle, ambient lubrication actively fed the porous ivory above, permanently locking the moisture out and preventing the ancient tusks from becoming brittle. So fool. Additionally, the dark mirrored surface of the still oil geometrically caught the limited sunlight, reflecting a highly calculated focused beam of ambiental illumination directly upward onto the statue's intricate facial features. Securing the foundation of the towering mausoleum required extensive subterranean engineering to conquer the persistent destructive flow of natural groundwater. Before the first marble block was laid, architects directed teams of miners to excavate a vast, deep, rectangular footprint directly into the living rock of the Halicarnassus hillside. Knowing the heavy seasonal rains would quickly turn this deep pit into a stagnant, eroding lake, engineers carved an intricate, highly calculated network of sloping drainage channels directly into the solid bedrock floor. These precise descending grooves systematically gathered the intruding groundwater, actively funneling the destructive moisture toward a massive, central subterranean aqueduct. To prevent heavy sediment from clogging this vital arterial system, the channels were meticulously lined with tightly fitted, unglazed terracotta pipes, specifically engineered to capture and redirect debris. This silent, continuous, and completely invisible hydraulic system flawlessly diverted thousands of gallons of water away from the structure, guaranteeing the heavy, stepped foundations would never shift, settle, or sink into the earth. The vertical assembly of the Colossus of Rhodes demanded a highly sophisticated, sequential method of bronze manipulation performed hundreds of feet in the air. As the internal iron framework slowly rose, metallurgists did not cast the deal. Massive outer plates in a single, unmanageable piece. Instead, they hauled large, flat sheets of hardened bronze directly up the earthen scaffolding. To seamlessly join these heavy metal plates, artisans employed a meticulous, exhausting technique known as cold hammer riveting. After perfectly aligning the overlapping edges of two plates, workers used hardened iron drills to bore perfectly matched, continuous rows of circular holes. Thick, heavy pins of slightly softer bronze were pushed directly through the openings. Using massive heavy mallets, workers rhythmically and violently hammered the protruding ends of the pins, physically crushing and mushrooming the metal until it permanently clamped the heavy plates together. This relentless, overlapping percussive force created an incredibly rigid, unified metallic skin, fully capable of withstanding the immense lateral pressure of the coastal winds. To protect the towering lighthouse of Alexandria from the devastating, continuous impact of hurricane-force winds and violent sea storms, the architects abandoned traditional, flat-stacked masonry. For the massive square lower tier, masons utilized a profoundly complex, highly interlocking method of stone placement known as polygonal masonry. Instead of cutting the heavy granite blocks into perfect uniform rectangles, each massive stone was painstakingly carved into a highly unique, multi-sided geometric shape. The adjacent stones were then meticulously chipped and ground down to perfectly match these irregular, jutting angles, locking together like an immense, three-dimensional puzzle. This brilliant, time-consuming structural decision completely eliminated the existence of continuous horizontal or vertical seam lines, which are the primary points of catastrophic failure in traditional walls. When the immense kinetic force of a crashing tidal wave struck the base of the pharos, the kinetic energy was seamlessly and instantly dispersed across the multifaceted joints, rendering the towering structure absolutely immovable against the roaring Mediterranean. The flawless, enduring cohesion of the Great Pyramid's core blocks relied entirely upon the meticulous, high-temperature refinement of a highly specialized gypsum mortar. Unlike modern cements that require moisture to cure, Egyptian chemists engineered a binding matrix that thrived in the absolute arid heat of the desert. Laborers gathered thousands of tons of raw gypsum rock, breaking it down, baking it continuously over roaring open-pit fires to completely drive out the natural crystalline water. This deeply dehydrated white powder was then quickly mixed with fine quartz sand and a highly calculated measure of fresh river water, creating a thick, rapid-setting paste. As masons levered the heavy limestone blocks into position, the mortar instantly began to chemically cure, expanding slightly to completely fill every microscopic void between the rough stones. Once fully hardened, this remarkable chemical compound became physically stronger and more resilient than the surrounding limestone itself, actively absorbing the natural tectonic shifts of the earth without ever crumbling or releasing its eternal grip, raising heavy, massive bundles of combustible fuel up the solid vertical core of the Alexandrian lighthouse required a sophisticated gravity-driven counterweight mechanism While pack mules navigated the lower spiral ramps, the final, terrifying, vertical ascent to the absolute peak demanded a brilliant mechanical elevator. Engineers constructed a wide, deep central shaft, plunging directly from the Adverts light chamber down to the middle tier. At the very top, they mounted a massive, deeply grooved wooden pulley wheel, turning smoothly upon a heavily greased axis of solid bronze. A thick, incredibly strong rope woven from braided hemp and papyrus was threaded precisely over this heavy wheel. On one end, a large, reinforced wooden platform was carefully loaded with heavy stacks of resin-soaked timber. On the opposite end, a massive lead weight was slowly, methodically guided down a parallel, highly restricted vertical chute. As the heavy lead plunged downward, the immense physical gravity effortlessly pulled the vital heavy fuel upward, guaranteeing the eternal fire continued to burn. To achieve the breathtaking, mathematically perfect true north alignment of the Great Pyramid, Egyptian surveyors relied entirely on the quiet, methodical observation of the nocturnal sky. Long before the massive limestone blocks were quarried, astronomers constructed a circular, perfectly leveled mud brick wall to block out the distracting, uneven horizon. Standing precisely in the center, a priest utilized a simple, beautifully crafted palm rib tool known as a merkhet, heavily weighted with a suspended lead plumb line. As the circumpolar stars slowly rotated through the dark, unpolluted sky, observer meticulously marked the exact point where a specific star rose over the near wall and the exact point where it quietly set. By drawing a line directly between these two distinct marks and mathematically bisecting the resulting angle, they discovered true geometric north with an astonishing, microscopic margin of error of less than 3/60ths of a degree. This profound, silent calculation dictated the entire orientation of the colossal, unyielding geometric mountain. Protecting the internal king's chamber from ancient intruders required the engineering of a massive, gravity-driven portcullis system directly within the antechamber. Builders carved 3 deep, vertical grooves directly into the solid granite walls flanking the narrow entrance. Into these precise slots, they suspended 3 monumental, multi-ton slabs of red Aswan granite, temporarily held high above the corridor floor by thick, dry ropes of twisted papyrus to support the immense hanging weight during the decades of construction. Architects inserted heavy wooden beams directly beneath the suspended stone gates. When the final funerary rites were complete, workers methodically chipped away the wooden supports and severed the thick, heavy ropes. The massive granite slabs heavily plummeted downward, sliding flawlessly through the greased vertical tracks to permanently seal the burial chamber. This profound, irreversible application of kinetic energy transformed the current's delicate, open corridor into an impenetrable solid wall of unyielding igneous rock, designed to protect the pharaoh in absolute, undisturbed silence. The colossal, terraced substructure of the Hanging Gardens relied upon the rapid, systematic mass production of millions of specialized sun-baked mud bricks. Babylonian laborers gathered along the muddy, slow-moving banks of the Euphrates, heavily mixing the dense, clay-rich river soil with precisely chopped straw and sharp sand. This vital aggregate provided essential tensile strength from crumbling as it dried. The wet, heavy mixture was aggressively pressed into uniform, rectangular wooden molds, quickly inverted and dropped onto vast, flat expanses of dry sand. Once the intense, baking heat of the Mesopotamian sun drew out the initial moisture, the bricks were carefully stacked in open geometric lattice patterns to allow the warm wind to completely penetrate the core. For the critical load-bearing arches, these dried blocks were transferred to massive, roaring kilns, slowly firing the clay until it vitrified into incredibly hard, water-resistant ceramic blocks, perfectly engineered to bear the crushing, immense weight of the elevated artificial forest. The intricate, sweeping vertical flutes along the colossal columns of the Temple of Artemis were not carved in the quarries, but meticulously ground into the marble only after the towering shafts were fully assembled. This brilliant logistical decision prevented the delicate, sharp edges of the fluting from being chipped or shattered during the heavy transport. Once the massive, stacked drums were securely locked together with internally bronze dowels, masons constructed towering, circular wooden scaffolding entirely around the standing column. Starting from the absolute peak and working methodically downward, artisans used sharp, heavy iron chisels to roughly gouge out the 24 deep, parallel, vertical channels. To achieve the flawless, deeply polished curves, they switched to custom-carved wooden blocks heavily coated in a thick, abrasive slurry of wet emery dust and olive oil. Rubbing these specialized, rounded tools relentlessly up and down the channels slowly erased every single chisel mark, yielding a pristine, continuous vertical geometry. The breathtaking, hyper-realistic details of the statue of Zeus were achieved through the delicate, highly specialized application of molten glass and semi-precious stone inlay. To create the piercing, divine eyes of the colossal deity, artisans did not rely on flat paint, but deeply carved into the curved ivory face. They carefully ground massive, pure pieces of clear rock crystal to form the rounded cornea, backing the translucent stone with a thin, highly polished sheet of gold foil to dynamically catch the flickering temple light. The dark, imposing pupils were cut from dense, jet-black obsidian, perfectly fitted into the crystal matrix. Along the heavy, solid gold folds of the gods' garments, jewelers meticulously embedded hundreds of flat, brightly colored glass tiles using a slow, thermal enameling process. By melting powdered, mineral-tinted glass directly into recessed carved beds within the gold, they created a brilliant, highly textured mosaic of geometric lilies and deep blue rosettes permanently fused into the heavy metal. The pristine, blinding white marble of the mausoleum was originally heavily saturated with brilliant, deeply applied colors, utilizing an ancient, waterproof technique known as encaustic painting. Greek artists could not simply brush water-based pigments onto the porous, salt-swept stone, as the harsh coastal storms would instantly wash the delicate work away. Instead, they meticulously ground heavy earth minerals like red ochre, toxical cinnabar, and bright malachite into a remarkably fine, dry dust. This vivid powder was aggressively mixed directly into pots of purified boiling beeswax and sticky pine resin, while the highly pigmented wax remained scalding hot and entirely liquid. Artisans rapidly painted it onto the carved marble friezes, using stiff, coarse brushes made of badger hair. Before the wax could fully harden, they passed a heavy, red-hot iron spatula directly over the surface of the stone. This intense, localized heat actively drove the liquid colors deep into the fey. Microscopic pores of the marble, creating an eternal, deeply vibrant, and perfectly waterproof seal. The immense, towering height of the Colossus of Rhodes required an internal skeleton of unparalleled structural complexity, far exceeding the simple iron pillars of its base. As the bronze outer shell expanded upward, chairs of lindos engineered a profound, highly tensioned three-dimensional web of forged iron bars. Blacksmiths hammered out thousands of thick, heavy iron struts, meticulously crossing and intersecting them at highly specific geometric angles to create a rigid, internal lattice. Where these heavy metal beams intersected, they were intensely heated until glowing red, then forcefully punched and pinned together with heavy, expanding rivets. This brilliant, multi-directional internal matrix acted exactly like the complex, weight-bearing spokes of a bicycle wheel. By transferring the immense, localized pressure of the heavy Mediterranean wind instantly across the entire internal skeleton, the architect ensured that the delicate, relatively thin bronze plates would never buckle or warp, silently holding the massive geometric shape perfectly intact against the roaring sky, protecting the towering joints of the Alexandrian lighthouse from the relentless, highly corrosive salt spray of the ocean. Demanded an incredibly permanent chemical waterproofing strategy. Masons tightly fitted the massive heavy blocks of solid Aswan granite, ensuring the horizontal seams were completely flush. Using sharply pointed chisels, they carved deep, continuous interlocking channels directly along the top edge of every single stone. Once a heavy tier was perfectly leveled and set, metallurgists built roaring, localized charcoal furnaces directly upon the sweeping stone platform. They aggressively melted massive ingots of raw lead until the heavy metal completely liquefied into a shimmering, heavy silver pool. Workers quickly carried long, heavy ceramic ladles filled with the molten metal, pouring the liquid directly into the deeply carved, interlocking stone grooves. The scorching lead instantly rushed into every microscopic crevice, rapidly boiling away any trapped moisture. As it cooled, it permanently solidified, creating an unbreakable, completely waterproof and highly flexible metallic gasket between the colossal granite blocks. The precision extraction of the brilliant white Tura limestone required a grueling, highly specialized method of abrasive friction cutting, as Egyptian copper tools were far too soft to cleave the stone directly. Deep within the subterranean quarry, masons marked the exact dimensions of a casing block directly onto the solid rock wall. Instead of heavy hammering, they utilized long, heavy copper saws, operated entirely by two men, pulling in a continuous, rhythmic and deeply exhausting motion. Because the smooth copper blade itself could not cut the dense limestone, a third worker continuously poured a wet, abrasive slurry of finely crushed quartz, sand and water directly into the expanding cut. It was the microscopic, diamond-hard grains of quartz, momentarily trapped beneath the heavy sliding copper blade, that relentlessly ground the limestone away. This incredibly slow, agonizingly patient process consumed the copper tools entirely, but left behind a perfectly straight, razor-sharp, and geometrically flawless cut, yielding the magnificent, glowing white stones of the pyramid's outer shell. The immense volume of liquid bronze required for the Colossus of Rhodes demanded a highly calculated, heavily industrialized system of localized metallurgy. At the absolute base of the earthen construction ramp, master founders excavated a series of deep, circular pit furnaces directly into the shoreline. These wide subterranean crucibles were heavily lined with thick, fire-resistant clay to reflect the intense, roaring heat inward. Workers packed the deep pits with dense layers of highly combustible pine charcoal, aggressively pumping heavy leather bellows to force oxygen into the chemo. Deep coals, driving the ambient temperature well above 2,000 degrees. Massive, heavy ingots of raw copper and brittle tin were precisely weighed and dropped directly into the glowing, white-hot ceramic pots. As the two distinct metals rapidly melted and chemically fused into a brilliant, liquid alloy, heavy, thick layers of toxic slag naturally floated to the surface. Artisans meticulously skimmed this dark impurity away using long wooden poles, ensuring the final, shimmering pool of liquid bronze was perfectly pure and structurally flawless. To maneuver the massive limestone blocks into the higher tiers of the Great Pyramid, some architects suggest the use of an ingenious internal spiraling ramp instead of a singular, massive external slope that would require more material than the pyramid itself. Builders may have constructed an open trench directly into the perimeter edges of the rising core. As the base grew, this wide, gently sloping corridor was systematically roofed over with heavy, overlapping corbelled blocks, creating a hollow, ascending tunnel just beneath the outer casing. At each of the 4 precise corners, engineers left large, open-air notches. These flat, unroofed turning platforms allowed teams of laborers to safely pivot the heavy wooden sledges 90 degrees using sturdy wooden cranes and lubricated timber fulcrums. Once the peak was finally reached, workers methodically worked their way back down, filling the open corner notches with flawless white casing stones quietly, sealing the sprawling hidden ramp system forever within the solid geometric mountain. An alternative, highly efficient method for raising thousands of gallons of water to the hanging terraces involved a massive, continuously looping chain pump. Babylonian engineers suspended 2 massive heavy wooden wheels, one anchored deeply in the flowing reservoir below, and the other mounted securely at the absolute peak of the mud brick vaults. A long, incredibly strong loop of braided hemp and copper chain was stretched tightly between these rotating drums. Evenly spaced along this continuous belt were dozens of heavy, watertight bronze buckets. As teams of laborers rhythmically turned the upper wheel using long wooden treadmills, the heavy buckets plunged downward, quietly scooping up the cool river water. The chain then pulled the filled vessels steadily upward in a flawless, vertical ascent. As each bucket crested the upper drum, it smoothly tipped forward, precisely pouring its liquid contents into a wide, shallow limestone aqueduct, which seamlessly distributed the vital hydration across the sprawling, elevated root systems. The defining architectural signature of the Temple of Artemis lay in the breathtaking, sweeping volutes of its massive Ionic capitals. To achieve this complex, spiraling geometry on a colossal scale, stonemasons did not rely on freehand carving. Instead, they utilized a highly precise mathematical tool called a compass of proportion. Before striking the marble, the master carver drew a perfect microscopic, geometric spiral onto a flat wooden board, calculating the exact mathematical ratio of expansion for every single turn. This precise grid was then meticulously transferred directly onto the rough-hewn marble block using charcoal dust and tightly snapped string lines. Following these intersecting reference points, artisans used heavy iron mallets and narrow, gouging chisels to carefully remove the negative space, slowly revealing the deep, rolling curves of the scrollwork. Finally, the deep channels were relentlessly polished with wet sand and tightly rolled leather straps, producing a flawless flowing contour that perfectly caught the soft Aegean light. The elaborate, towering throne of the Olympian Zeus was not merely a wooden support, but an architectural masterpiece of intricate, microscopic joinery. To decorate the massive cedar frame, without using heavy structural nails, Phidias employed a profoundly delicate technique known as intarsia. Master carpenters carved thousands of incredibly shallow, highly geometric depressions directly into the legs and armrests of the wooden throne. They specifically gathered exotic materials from across the ancient trade. Roots slicing dense, black African ebony and bright, reflective glass into incredibly thin, uniform geometric tiles. Using a strong, heat-activated glue made from boiled animal hooves and fish bladders, artisans carefully pressed these delicate tiles directly into the carved wooden recesses. The contrasting materials were meticulously arranged to depict mythological sphinxes and triumphant athletes. Once the glue set, the entire surface was aggressively rubbed with fine pumice stone, ensuring the glass, ebony, and cedar were perfectly flush, creating a seamlessly smooth, endlessly detailed surface. Crowning the stepped, pyramidal roof of the Halicarnassus mausoleum was a colossal, multi-ton marble chariot pulled by 4 massive, rearing horses. To ensure this incredibly heavy, top-heavy sculpture did not fracture and plummet from the soaring peak, architects engineered a brilliant distribution of dead weight. Rather than carving the magnificent horses from solid blocks of marble, which would be catastrophically heavy, the sculptors deeply hollowed out the internally chests and bellies of the animals. Using long, heavy iron drills, they meticulously removed thousands of pounds excess stone from within, leaving a remarkably strong, relatively thin marble shell. To prevent the hollowed legs from snapping under the remaining weight, thick, hidden iron dowels were driven directly down through the hooves and deeply anchored into the flat pedestal stone using molten lead. This invisible, highly calculated reduction of mass allowed the colossal, dynamic monument to balance flawlessly upon the narrowing apex of the geometric roof. As the internal iron and bronze skeleton of the Colossus grew steadily higher, the engineers faced the monumental challenge of safely delivering multi-ton bronze plates hundreds of feet into the air. Traditional wooden scaffolding would violently sway and buckle under the immense weight. Therefore, chairs of lindos directed the construction of a massive, continually expanding earthen ramp that completely swallowed the lower portions of the statue as it rose. Thousands of laborers carried heavy woven baskets of dense clay and crushed limestone, methodically dumping and tightly compacting the earth around the bronze figure. To prevent this sprawling artificial hill from collapsing under its own massive weight or sliding away in the heavy coastal rains, engineers continuously reinforced the sloping sides with thick, interlocking walls of heavy pine timber and tightly woven willow branches. This sprawling, solid earthen mountain provided an absolutely rigid, unmoving platform for the metallurgists to to safely hammer the glowing rivets at terrifying, wind-swept heights. Operating the massive, continuously burning beacon at the absolute peak of the Alps, Alexandrian lighthouse required constant, flawless communication between the ground-level fuel suppliers and the high-altitude hearth-keepers. Because the roaring winds of the Mediterranean and the immense 400-foot vertical distance made shouting entirely impossible, architects engineered the central, hollow core of the structure to act as a colossal acoustic amplifier. A completely unobstructed, vertical stone shaft dropped straight down the center of the spiraling supply ramp. The smooth, incredibly dense interior walls of Aswan granite were meticulously polished to reflect sound waves with minimal atmospheric distortion. To relay critical instructions, the hearthkeepers at the summit possessed a long, heavy bronze horn. When they blew a specific, low-frequency blast directly down the central shaft, the deep, resonating sound wave violently bounced off the polished granite wall safely and instantly, carrying the acoustic signal all the way down to the echoing, subterranean supply vaults below. The installation of the massive dark granite sarcophagus deep within the king's chamber reveals a profound sequential mastery of construction logistics. Because this immense, hollowed-out block of solid Aswan granite was physically wider than the narrow ascending corridors leading up to the chamber, it could not possibly have been carried inside after the pyramid was completed. Instead, the architects placed the heavy sarcophagus directly onto the flat limestone bedrock exactly when the burial chamber's floor was being laid. As the surrounding, multi-ton granite walls and towering relieving chambers meticulously built up around it, the dark stone box sat quietly, exposed to the open desert sky. The entire colossal mountain of limestone was then methodically stacked and assembled over it, permanently entombing the sarcophagus in absolute geometric darkness. This brilliant foresight guaranteed the perfect undamaged placement of Pharaoh's final resting place, long before the first sloping ceiling block of the Grand Gallery was ever cut. Cultivating massive, deeply rooted trees upon the elevated brick arches of Babylon required precisely calculated depths of heavy organic soil, introducing a terrifying amount of structural compression to minimize the crushing weight while maximizing botanical nutrition. Engineers did not simply pile random dirt onto the lead-lined terraces. They developed a highly refined, lightweight aggregate mixture. The deepest foundational layer consisted of large, highly porous chunks of oil, hardened charcoal, and shattered terracotta pottery, which provided massive volume and excellent drainage while remaining incredibly light. Over this, laborers spread a carefully balanced matrix of fine river silt, rich in organic compost, and dry, crushed reeds. This specifically engineered horticultural soil held moisture brilliantly, without compacting into dense, heavy mud. To prevent the deep tree roots from fiercely anchoring into the masonry and ripping the arches apart, the soil beds were meticulously shaped into thick, distinct geometric mounds, guiding the aggressive root systems laterally along the flat, impenetrable lead barrier. To ensure the monumental temple of Artemis did not violently sink into its sick, highly specialized, shock-absorbing marsh foundation, Greek architects had to constantly manage the aggressive intrusion of localized groundwater. They surrounded the entire massive footprint of the temple with a deep, continuous, sloped perimeter trench, meticulously paved with smooth, unglazed terracotta tiles. This highly precise channel passively gathered the heavy, seeping swamp water away from the crushed charcoal and sheepskin base. To evacuate the collected water, engineers relied upon an early, continuous application of the Archimedean screw. Slaves worked in shifts, rhythmically turning the heavy wooden handles of multiple pitched screw pumps that reached deep into the collection trenches. With every deliberate, splashing rotation, the internal helical chambers scooped the groundwater upward, smoothly depositing it into a wide, descending stone canal that safely carried the moisture away into the nearby Caister River. This continuous, quiet pumping maintained a perfectly balanced, deeply stabilized hydrological environment beneath the colossal marble columns. To provide continuous air circulation to the deep internal chambers, Egyptian engineers constructed perfectly straight, highly angled ventilation shafts that penetrate hundreds of feet through the solid pyramid core. Unlike modern pipes laid into a pre-existing wall, these narrow conduits had to be meticulously built layer by layer as the massive structure rose. Masons carefully selected specific, elongated limestone blocks, copper chisels to carve a deep, perfectly U-shaped trough directly into the top surface of the stone. When the next horizontal course of flat masonry was laid directly above it, the open trench was seamlessly roofed over, creating a continuous, hollow square tube measuring a mere 8 inches across. By precisely angling the base of these grooved blocks, the builders maintained an unbroken, mathematically flawless, diagonal trajectory through millions of tons of surrounding rock. This profound, deeply calculated geometry allowed the narrow shafts to successfully pierce the outer casing stones, permanently connecting the silent, heavy darkness of the burial chamber to the eternal circulating winds of the desert sky. Long before the towering superstructure began to rise, surveyors orchestrated the excavation of a massive plunging subterranean corridor directly into the solid line subterraneans. To maintain an absolutely flawless descent angle of exactly 26 degrees. For over 300 feet, the engineers utilized a brilliant, gravity-based alignment system. They stretched a long, taut cord of braided flax straight down the dark, narrow tunnel, suspending heavy lead plumbs at meticulously calculated intervals. Working entirely by the flickering low-oxygen light of castor oil lamps, miners used heavy dolerite hammerstones and hardened copper picks to chip the bedrock away, inch by agonizing inch. Because the confined, subterranean space could only accommodate 1 or 2 laborers at a time, the progress was incredibly slow and deeply rhythmic. The fractured limestone debris was continuously scooped into small woven baskets and passed backward up the steep incline in a quiet, unbroken human chain, slowly carving a mathematically perfect geometric void deep beneath the ancient, unyielding desert floor, protecting the delicate, moisture-dependent root systems of the elevated gardens from the aggressive, baking heat of the Mesopotamian sun. Required a highly specialized method of thermal insulation. Babylonian engineers understood that solid sun-baked brick would rapidly transfer lethal heat directly into the soil beds. To prevent this botanical catastrophe, they constructed the towering outer retaining walls, utilizing a brilliant, complex double-wall design. Masons laid 2 entirely separate parallel walls of heavy-fired brick, deliberately leaving a wide, continuous gap of empty space perfectly sandwiched between them. This hollow internal cavity was then densely packed with tightly bundled layers of dry river reeds and highly porous date palm fronds. This dense, organic matrix trapped millions of microscopic pockets of stagnancy, air, functioning exactly like a thick, natural thermal blanket. This invisible, highly effective barrier actively blocked the relentless solar radiation, guaranteeing that the deep, heavy soil beds remained profoundly cool, perfectly moist and deeply hospitable to the colossal, transplanted mountain trees thriving above the arid plains, while the colossal architraves were lowered via sandbags, lifting the thousands of smaller, multi-ton marble blocks into the high walls of the Artemis Temple, required the sophisticated mechanical advantage of the compound pulley. 1. Greek engineers constructed towering, heavy wooden cranes from massive cedar beams, securely bracing them against the rising masonry. At the absolute apex of the wooden jib, they mounted a complex block containing multiple, deeply grooved bronze wheels. A remarkably thick, heavily braided cable of hemp fiber was threaded back forth between the upper block and a lower block, attached directly to the heavy stone. Instead of relying on exhausting human pulling force, the rope was securely wrapped around a massive, vertically mounted wooden capstan stationed firmly on the ground. As a slow, deeply patient team of heavy oxen rhythmically walked in a continuous, unbroken circle, the massive wooden cylinder turned, slowly wrapping the cable and gracefully multiplying the kinetic pulling force. This brilliant mechanism effortlessly and safely hoisted the gleaming marble into the sky. Before the first colossal marble drum was rolled onto the shock-absorbing marsh foundations, the priests and architects performed a quiet, profoundly precise, geometric ritual known as the foundation deposit, to permanently consecrate the absolute center of the towering columns. Masons carved a small, perfectly square depression directly into the heavy, flat plinth stone. Into this dark, hidden recess, they meticulously placed a highly specific collection of precious, beautifully minted electrum coins, heavy silver ingots, and small, intricately carved figurines of solid gold and polished bone. These precious objects were not randomly scattered, but mathematically aligned to the cardinal directions of the temple's geometric grid. Once the objects were perfectly seated, the masons poured a thin sealing layer of white lead directly over the treasure. The first massive, multi-ton marble base was then carefully levered perfectly into position, forever sealing the golden offerings beneath thousands of tons, unyielding stone, quietly anchoring the soaring architectural masterpiece with an invisible, eternal core of profound wealth and sacred geometry. The intricate, microscopic joinery required to seamlessly bind the massive plates of ivory and gold to the internal wooden skeleton of the Olympian Zeus demanded an absolute mastery of material expansion. Phidias and his master carpenters knew that driving heavy metal nails into the delicate ivory would instantly cause the fragile material to catastrophically shatter. Instead, they utilized a highly complex system of blind mortise and tenon joints. Artisans meticulously carved tiny, recessed square sockets into the back of each shaped ivory panel. They specifically harvested incredibly dense, heavily aged African ebony wood, carving thousands of tiny, perfectly matched wooden pegs. These small ebony dowels were dipped in a hot, deeply binding animal hide glue and pressed into the wooden skeleton. The heavy ivory plates were then gently pushed onto the protruding pegs, As the warm glue naturally cooled and contracted, it powerfully pulled the delicate ivory absolutely flush against the supporting frame, resulting in a flawless, sweeping divine surface free of any visible structural hardware. To achieve the incredibly deep, lifelike, and deeply shadowed folds of drapery on the towering marble statues of the mausoleum, Greek sculptors utilized a highly advanced mechanical cutting tool known as the running drill. Traditional iron chisels could only strike the outer surface of the stone, making deep undercutting entirely impossible without shattering the delicate marble limbs. The running drill consisted of a long, thin iron bit securely mounted into a rotating wooden shaft. A worker forcefully wrapped a taut, heavily greased bowstring entirely around the wooden handle. By rapidly, rhythmically sawing the bow back and forth, the iron bit spun at an incredibly high, continuous velocity. The master sculptor firmly guided the spinning metal point directly into the hard marble, slowly grinding deep, continuous, and highly controlled tubular channels straight through the solid stone. This relentless, mechanized friction safely removed the deeply hidden negative space, allowing the heavy marble garments to remarkably appear as though they were softly, gracefully blowing in the coastal Mediterranean wind. Constructing the immense, unyielding internal skeleton of the Colossus required the continuous, heavily industrialized production of forged iron on an unprecedented, monumental scale. Master blacksmiths built a sprawling network of heavily insulated, subterranean bloomery furnaces directly along the Rhodian shoreline. Workers packed the roaring clay chimneys with alternating dense layers of rich iron ore and highly combustible pine charcoal. As teams relentlessly pumped massive leather bellows, the intense thermal environment chemically stripped the oxygen from the ore, yielding a heavy, glowing, spongy mass of raw iron known as a bloom. To remove the brittle silica slag, workers pulled the blindingly hot mass from the fire and dragged it to a massive stone anvil. Utilizing heavy water-powered trip hammers, the raw metal was violently, rhythmically pounded. This immense percussive kinetic energy literally squeezed the liquid impurities directly out of the metal, repeatedly folding and compressing the cooling iron into incredibly dense, highly resilient structural beams perfectly engineered to support the towering heavy bronze architecture above. To protect the massive, towering foundation of the Alexandrian lighthouse from the relentless, deeply destructive kinetic energy of crashing tidal waves, engineers constructed a colossal, artificial underwater breakwater. Because diving and laying stones by hand in the turbulent, deep sea was entirely impossible, the Ptolemaic architects utilized a brilliant gravity-driven method of marine deposition. They constructed a fleet of massive, flat-bottomed wooden barges, specifically engineered with large, heavy trapdoors built directly into the lower hulls. These heavy barges were towed to the distant coastal quarries and loaded with thousands of massive, jagged, unshaped blocks of dense granite and heavy limestone. Teams of rowers carefully guided the heavily burdened ships to precise, mathematically calculated coordinates perfectly mapped around the Pharos Island. Upon a synchronized command, workers violently knocked away the heavy wooden retaining pins. The heavy trapdoors instantly swung open, quietly and forcefully dropping thousands of tons of solid rock directly into the dark, swirling depths, methodically building an immense, unyielding geometric reef entirely hidden beneath the waves. The soaring, 400-foot elevation of the Pharos Lighthouse was structurally achieved through a brilliant, highly calculated transition of 3 distinct geometric tiers, expertly engineered to safely transfer immense downward compression. The colossal, solid lower tier was constructed as a massive, heavy square, providing a profoundly wide, unmoving footprint to absorb the roaring coastal winds. Directly upon this square base, masons constructed the second tier as a perfect, sweeping octagon. By meticulously angling the heavy granite blocks of the octagonal base across the solid corners of the lower square, the engineers brilliantly distributed the crushing vertical load downward through 8 completely independent structural load paths, effectively cutting the localized pressure in half. Finally, the topmost tier, holding the heavy bronze mirror and roaring fire, was built as a perfectly smooth aerodynamic cylinder. This flawless, upward-stepping reduction of shear volume and surface area mathematically minimized the devastating wind resistance at extreme altitudes, allowing the towering, geometric beacon to stand absolute and unyielding against the chaotic Mediterranean storms. To ensure the brilliant white limestone casing stones of the Great Pyramid remained absolutely flush against one another, Egyptian masons engineered joints so microscopically tight that not even a single human hair could pass between them. But this was not achieved by simply pressing rough stones together. Masons applied a highly specialized, incredibly thin slurry of liquid gypsum mortar to the perfectly flat side of the resting block. The incoming multi-ton stone was then forcefully levered into place and aggressively rubbed back and forth against its neighbor in a massive, grinding motion. This immense, high-pressure friction actively squeezed the excess water and air directly out of the thin mortar joint. The resulting microscopic vacuum effect permanently chemically fused the 2 separate limestones into a single, unbreakable, continuous surface. This brilliant structural cohesion guaranteed that the towering aerodynamic faces of the pyramid would flawlessly shed heavy seasonal rains, preventing devastating internal water erosion for millennia to come. Managing the heavy continuous flow of thick river silt from the Euphrates required the Babylonian engineers to construct an intricate passive filtration system before the water ever reached the ascending mechanical pumps. At the absolute base of the Hanging Gardens, surveyors excavated a series of deep, interconnected settling pools lined with baked clay. As the rushing river water was diverted into the first, widest basin, sudden dramatic decrease in kinetic current allowed the heaviest, most destructive particles of mud and sand to naturally sink to the bottom. The surface water then gently spilled over a shallow brick weir into a secondary, much deeper pool, where finer suspended sediment was methodically filtered through submerged, woven mats of densely packed marsh reeds. Only this pure, thoroughly clarified water was finally permitted to enter the heavy bronze buckets of the chain pumps. This silent, unceasing hydraulic purification protected the delicate, elevated root systems from suffocating and prevented the vital irrigation channels from catastrophically clogging with heavy clay. To safely channel massive volumes of seasonal rainwater away from the delicate, painted marble facades of the Temple of Artemis, Greek architects engineered a deeply complex, continuous perimeter drainage system known as a cyma. Instead of allowing the heavy roof runoff to cascade chaotically over the sides, Carpenters constructed a raised, sloping terracotta lip entirely around the outer edge of the massive timber roof. This continuous channel actively gathered the rushing water, forcing it to flow laterally toward highly specific, mathematically spaced release points. At these precise intervals, sculptors carved massive, protruding marble lion heads directly into the heavy cornice blocks. The open, roaring mouths of these majestic stone beasts were deeply hollowed out, using long rotating iron drill bits connecting directly to the internal terracotta gutters. When the heavy storms arrived, the geometric system violently accelerated the water pressure, forcefully projecting the destructive moisture far away from the fragile foundation, silently preserving the towering colonnades in absolute, pristine structural condition. Supporting the colossal, localized weight of the 40-foot seated Zeus required Phidias to engineer a deeply complex hidden architectural substructure, completely separate from the visible decorative throne. Because the immense downward compression of the solid gold and heavy ivory would effortlessly shatter the intricately carved ebony legs, a massive, unyielding inner skeleton was constructed from heavy squared beams of seasoned oak. These thick, load-bearing pillars were driven completely through the hollow interior of the decorative throne, sinking deeply into massive, pre-carved sockets within the solid Eleusinian marble floor. To prevent these towering wooden pillars from buckling under the extreme vertical pressure, carpenters installed a continuous, highly tensioned grid of horizontal iron cross braces permanently bolted directly into the temples surrounding stone walls. This invisible, heavy-duty industrial framework actively absorbed every single ounce of the crushing kinetic energy, allowing the beautiful, delicate exterior of the divine throne to sit in a state of perfect, unburdened, and eternal structural peace. The breathtaking, elevated colonnade of the mausoleum at Halicarnassus, known as the Peron, required a brilliant mastery of geometric load distribution to support the massive pyramidal roof without utilizing solid interior walls. Architects erected 36 towering, fluted columns of pure white marble, mathematically spacing them to create a soaring open-air gallery. To safely bridge the wide, empty gaps between these isolated pillars, engineers utilized massive, perfectly uniform horizontal beams of solid marble called architraves. Because stone is incredibly weak under tension and prone to snapping across wide spans, the architects mathematically calculated the absolute maximum safe distance between the column centers. They then precisely carved the overlapping joints of the architraves to rest directly over the absolute geometric center of each supporting capital. This flawless, interlocking grid of heavy stone seamlessly gathered the crushing downward compression of the 24-step roof, safely driving the immense vertical kinetic force straight down the unbroken vertical shafts of the columns to the solid foundation below. To cast the breathtakingly massive, curved bronze plates of the Colossus, Rhodian metallurgists engineered a highly specialized system of localized, multi-layered clay molding. Artisans first constructed a heavy, rough internal armature of hammered iron wire bent exactly to match the sweeping muscular contours of the Titan's leg, or torso. This coarse framework was entirely packed with a dense, highly porous mixture of river mud and heavily crushed horse manure, providing exceptional thermal insulation. Over this core, they sculpted the flawless anatomical wax layer, The final, most critical step involved painting the delicate wax with an incredibly fine, liquid slip made from deeply purified, levigated clay. By applying dozens of microscopically thin, overlapping layers of this pure clay, over several weeks, they created an outer shell that could capture the exact texture of a human fingernail, yet withstand the catastrophic, exploding thermal shock of the 2,000-degree molten bronze as it violently raced into the dark, hidden void. To protect the colossal, weight-bearing foundation of the Alexandrian lighthouse from the relentless, dissolving chemical power of the saltwater tides, Ptolemaic engineers employed an astonishing, highly unconventional material. Historical accounts suggest the architects directed the localized mass production of enormous heavy blocks of solid cast glass. Because glass is fundamentally completely impervious to the corrosive, eroding salts that naturally destroy limestone and mortar, these heavy, translucent slabs were systematically laid directly into the deepest, submerged trenches of the excavated bedrock. Masons carefully stacked the massive granite blocks of the first structural tier directly upon this unyielding, chemical-resistant glass foundation to ensure absolute stability against the grinding tectonic shifts of the coastal fault line. Heavy sheets of pure lead were hammered flat and squeezed directly between the glass and the stone. This brilliant multi-material buffering system provided a deeply insulated, perpetually waterproof anchor for the towering geometric marvel rising silently above the chaotic, crashing waves of the Mediterranean, maintaining the razor-sharp cutting edge of the thousands of copper chisels used to carve the Great Pyramid required a continuous, highly industrialized system of localized metallurgy and rhythmic code forging. Because pure copper is a remarkably soft metal, the heavy, aggressive friction of carving dense limestone instantly blunted the blades, rendering them useless. After merely a few dozen strikes, to conquer this material limitation, the masons employed a brilliant physical process of continuous atomic compression. Every single time a chisel dulled, it was not immediately tossed into a melting furnace. Instead, a specialized worker placed the warm, blunted tip directly onto a heavy, flat basalt anvil. Using a smooth, dense hammerstone, they rhythmically and violently beat the edge of the copper tool. This relentless percussive force physically compacted the metallic crystalline structure, pushing the copper atoms closer together in a process known as work hardening. This silent, repetitive beating instantly restored a brilliantly sharp, highly durable edge, allowing the carving of the geometric mountain to continue without pause, to provide continuous, deeply refreshing relief to the royal inhabitants. Wandering the shaded terraces of Babylon, the architects engineered a brilliant, entirely passive system of atmospheric air conditioning, integrated directly into the towering, thick mud brick walls. Builders constructed tall, hollow vertical shafts known as wind catchers. These narrow aerodynamic chimneys extended high above the leafy canopy, specifically angled to physically intercept the fast-moving cooler air currents sweeping across the upper atmosphere of the Mesopotamian plains. The geometric shape of the towering catchers forcefully funneled the rushing breeze downward into the dark subterranean masonry. As the hot, arid wind plunged vertically through the shafts, it was methodically directed over the cool, damp, heavy terracotta water pipes feeding the gardens. This highly calculated thermal exchange rapidly cooled the air, forcing a gentle, continuous and remarkably chilled breeze to quietly spill outward into the lower shaded colonnades, perfectly conquering the hostile, baking heat of the ancient desert. To prevent the colossal, 60-foot marble columns of the Temple of Artemis from appearing visually concave or structurally weak from a distance, architects masterfully employed an imperceptible geometric optical illusion known as entasis. If the massive fluted cylinders had been carved perfectly straight from the base to the capital, the human eye would naturally perceive them as dangerously pinched in the middle. To correct this inherent biological distortion, masons utilized complex, sweeping mathematical arcs, as they meticulously stacked and ground the heavy column drums. They deliberately increased the girth of the middle sections by exactly a few microscopic fractions of an inch. This highly calculated, gentle outward swelling made the towering marble pillars appear visually swollen with the immense, crushing compression of the heavy roof. This profound, silent manipulation of human perspective gave the soaring, rigid stone architecture an organic, deeply muscular, and heavily grounded tension, securing the divine illusion of absolute structural perfection. And now, as the long golden light of the ancient sun finally begins to fade, our journey across the ancient Mediterranean must also come to a gentle, peaceful close. The heavy, rhythmic striking of the bronze chisels has finally ceased. The immense creaking wooden wheels and the heavy braided ropes have fallen perfectly silent. The master architects, the brilliant geometricians, and the countless patient laborers have long since laid down their heavy tools, finding their own eternal, well-deserved rest beneath the quiet earth. The colossal, magnificent structures they left behind no longer echo with the demanding sounds of industry. The massive polished marble columns and the soaring, unyielding limestone mountains now stand in absolute unbroken stillness, sleeping peacefully beneath the vast rotating canopy of the starlit sky. Let the heavy golden dust slowly settle over the faded, ancient papyrus blueprints. Feel the heavy internal bronze gears quietly grind to a final, peaceful halt as the magnificent, ancient wonders gently fade away into the cool, comforting shadows of the night, leaving behind a world that is perfectly calm, perfectly still, and entirely at peace. It is time now to leave these towering ancient memories to their silent slumber and allow your own weary, racing mind to slowly return to the quiet reality of this present moment. Feel the soft, familiar weight of your own blankets, wrapping safely and warmly around you, like a thick, protective layer of enduring peace. The colossal, sun-baked stones have softly given way to the deep, yielding comfort beneath your fingertips. You are entirely safe here, completely sheltered from the heavy, demanding currents of the waking world. Take one last, slow, and incredibly deep breath in, filling your chest with calm, quiet, and deeply purifying air. And as you exhale softly, release every final trace of tension from your tired body. Let your shoulders sink heavily into the mattress. Feel the muscles in your face soften and smooth away. And allow your arms and your legs to become wonderfully heavy, completely and absolutely relaxed. There is nothing left to build today. Nowhere else you need to be. Just this perfect, unbroken stillness. Completely surrendering your resting mind and your quiet body to the gentle, eternal embrace of the night. Sleep well, and good night.